Hey folks, thanks for tuning in. My name is Patrick Helm. I'm a grad student here at the University of Tennessee, and I'm going to talk to you about my study entitled Predicting the Movements of Wild Hogs in Great Smoky Mountains National Park and Big South Fork National River and Recreation Area. The purpose of my study is to predict the seasonal movements and habitats of wild hogs to help these parks come up with an efficient way to eradicate these animals. We'll start out with a little information about hogs, Sus scrofa. Wild hogs are native to Eurasia and northern Africa. They were first introduced to the southern part of North America as early as the 1500s by Spanish explorers. Some of the problems that wild hogs pose is that they are extremely invasive. They are destructive to soil and vegetation, and they are known to consume both rare and endangered species. They also harbor several dangerous diseases, such as pseudorabies and swine brucellosis. It is estimated that hogs cause $120 billion in annual economic losses in the United States. There are several management challenges that come with wild hogs in the Smokies and Big South Fork. Hogs are highly adaptable and extremely intelligent. Their reproductive rates are higher than most species, having as many as 2 litters a year with 1 to 12 piglets per litter. Hog numbers continue to stay consistent due to illegal releases on or near park boundaries in both study areas. My study will take place in 2 different national parks. The first is the Great Smoky Mountains National Park. It's located on the western North Carolina-East Tennessee border. Hogs first came to the park in the 1930s after a hunting camp enclosure in Hoopers Bald, North Carolina was breached a few miles from Fontana Lake. They made their way across the landscape towards the Smokies and bred with local livestock pigs, creating a new hybrid wild hog. My second study area is Big South Fork National River and Recreation Area, located on the East Tennessee and Kentucky border. In the 1960s, hogs were released from a hunting lodge in the center of what is now Big South Fork and quickly established home ranges in surrounding areas. Some reasons for the need for this study is that hogs are negatively affecting the natural diversity of the parks. The environmentally sensitive species and ecosystems must be protected. Also, the hog program was established in the 1960s, and managers today need more effective and efficient solutions. We must understand hog movements so that we can locate and kill them. We want to preserve these parks by reducing the wild hog populations. Here are some hypotheses that will be tested in this study. Wild hog movements and activity patterns can be predicted based on ambient temperature, time of day, and time of season. Hogs with origins outside the parks can be identified through stable isotope analysis of dietary history and construction of a timeline using carbon and nitrogen ratios in tooth samples. Combining Judas pig management with established hog removal techniques can create a more efficient population management program. Here is how I plan to acquire the wild hog movement data. First, the hogs will be trapped, preferably during the winter months to avoid trapping non-target species such as bears and white-tailed deer. The traps are semi-permanent, guillotine-style box traps located throughout both parks. We will bait the traps using a mix of shelled corn and mineral salt. After trapping, the hogs will be immobilized using BAM, a 3-drug combination consisting of butorphanol, azaparone, and medetomidine. Some advantages of using BAM are quick induction times, and it is reversible. After they're immobilized, we will fit the hogs with a GPS collar. Currently, we have 6 collars that were purchased by the Eastern Band of Cherokee Indians. They're made by the Vectronic software company, manufactured in Germany. The collars are programmed to collect 1 fix every hour, and those fixes are uploaded every 4 hours. The GPS collars have store onboard data. Ideally, for this project, we would like to collar at least 15 total hogs, both male and female. Presently, we have captured and released 9 hogs, 4 males, 5 females. The purpose of these collars are to find out where the hogs are and how are they getting there. As part of my study, I will also do a stable isotope analysis. A stable isotope is an element, like carbon or nitrogen, that has a unique atomic mass that does not undergo decay. When consumed, the elemental composition of that food item is absorbed into various tissues throughout the body. This analysis can allow us to use the cementum annuli, or the annual rings and teeth, to construct a dietary timeline. Using the timeline, we may be able to detect abnormalities in the early diet of a hog, which may indicate that the hog was introduced from outside the parks. Near the end of the study, I will compile all the movement data collected by the GPS collars. I will compare both male and female movements based on elevation, temperature, humidity, moon phase, and atmospheric pressure. With that, I will identify the habitat and home range selection using ArcMap. I will also construct a step selection function model that will predict the most likely routes a hog travels from one food source to the next. I have previously performed a few data analysis simulations using R. I ran a basic t-test to look at unequal variances in hourly movements of both male and female hogs. I also ran an ANOVA test to detect any movement variation between seasons for males and females. For this study, I will also test for interactions between sex, season, and weather. I will conduct, in R, multiple comparison tests such as Duncan, Student Newman Cools, Tukey, and Bonferroni to assess male and female traveling patterns. I'd like to take the time to thank the folks who made this study possible. We'll start with the University of Tennessee, my advisor, Dr. Joe Clark, several of my colleagues from both the Great Smoky Mountains National Park and Big South Fork, the Eastern Band of Cherokee Indians, and the National Park Service. Thanks for your time, and have a great day.